median is the value, the data value that is in the middle of our arranged data value, or data values. The data value Okay, so we arrange our data in order from least to greatest, and we find the one that falls in the middle. If we have an odd number of values, then there's the one that's in the middle, the value in the middle. If we have an even number of values, then we find the mean of the middle two. Okay. All right, so we arrange the values in order, and then we pick either the middle or the mean of the middle two. Okay, some properties of the median. It is resistant. That's the first thing. Resistant means that it's not affected by extreme values. Okay. Okay. The disadvantage, what do you think might be compared to the mean? Not a true middle? Okay, what do you mean by that? That's it. Okay, we don't use all the values. The median does not use all the values. Okay, so if we wanted to find the median of the 20 enrolled credit hours for students from our class, I'm going to just flip back here and look at our arranged data. But that's I didn't arrange it here because I wanted you to know step one is to arrange the data in order. Okay, so you would do that first, arrange the data in order. And once we have it arranged in order, we've got 20 values. So what are we going to do to find the median? Okay, the mean of the middle two. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my middle two. So my median would be what? 9.5. Very good. And I didn't mention, this is not commonly used, but this author does use this symbol to represent the median, X tilde. I would just say the median. Okay, 9.5. All right. Questions about that? All right, again, if we were to look at that data and change, this wouldn't be relevant for credit hours, but if we had data where we could change this to 160, what would the median be? It'd still be 9.5, right? So it's not really taking into consideration all of these values, you know, just the number of values. The median for when we have this set as 16 versus 160 is the same thing. Okay. All right, but on the other hand, the good thing is it's not affected by this extreme value. Okay. All right, very good. Okay, listed below are the amounts of mercury in parts per million found in tuna sushi sampled at different stores in New York City. Find the median for the given sample data. Okay, so the first thing we need to do is what? Put it in order. Okay, and so if I put it in order, help me out here. Looks like we got 0.1, 0. Okay. 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 Very good. Okay, we've got them in order now. How many values do we have? 7. Okay, so to get the median, we're going to look at just the what? The middle one, which would be number 4, 0.75. So our median is 0.75. Okay. I mean, it should go without saying, but I'll say it, that the median is the middle because we got half of the values below it and half of the values above it. Okay, so it doesn't really look at how the values are dispersed, but it does count the number of values so that we have 50% above and 50% below. Okay, that's our median. All right, excellent. All right, now we're going to talk about the mode, which is just the value that occurs, and I'm going to add the word data value, that occurs most frequently. Okay, the data value that occurs most frequently. Now I think it's pretty obvious why that might be a measure of center or what we'd consider to be a typical value. Okay, unique characteristic of the mode is that it's the only measure of data used for qualitative data, or only measure of center used for qualitative data. Okay, only measure of center used for qualitative data. Some other things that we should know about the mode is the mode, first of all, doesn't have to be unique. So if we have a data set that has 2 values that occur more than all the other values, but they occur the same number of times, we would say that that data set is bimodal. Okay, and then some textbooks like ours even talks about multimodal data. Okay, we've got data values that occur the same number of times and more than everybody else. Okay, and in this case, if we're talking multimodal, it's more than 2 of these values. At some point, though, that information becomes meaningless. You know, you got 5 modes. That doesn't tell us anything. And we can also have no mode. Okay, if our data values are not repeated, or if they're repeated the same number of times, then we would have no mode. Okay, so that's a little problem with the mode. I mean, bottom line, it may not exist, or we may have multiple values for the mode. Okay, but really good measure for qualitative data. Okay, so here I have some data that represents the diagnosis of a random sample of 23 patients admitted to a hospital. What is the best measure of central tendency, and what is that data value? Okay, how would we answer the first question? What's the best measure of central tendency? The mode. Why the mode? Because it's qualitative data. We can't calculate a mean here. We can't calculate median. The only thing we can do with qualitative data is the mode. Okay, so we'd have to use the mode here. All right, and what is the mode? Okay. All right, the mode looks like you all said gunshot wound. Very good. All All right, excellent. Okay, I wanted to point something out to you. Let's look at this next example. Okay, I want you to think about it for a second. This is, what do we call this chart? Frequency distribution, and in particular, what kind of frequency distribution is it? Starts with a C. Categorical. Okay, this is a categorical frequency distribution because we have categorical data. Okay, so looking at this, what would you say the mode is? Okay. All right, I got one vote for 1. Anybody else? Everybody says 1? No? Okay, we've got one head shaking no. What would you say it is? Gunshot wounds. It's gunshot wounds. Okay, this is a summary of data. This is the same data that we have above, right? This is just a summary of it. It tells us that there was 1 value of cancer, 7 of motor vehicle accident, 1, and so forth and so on. So if we wanted to reconstitute the data, I would write cancer once, motor vehicle accident 7 times, and all of these things, gunshot wounds 8 times. So it looks just like it does above. And so when we do that, when we think about what the variable is or what the question is that's being answered. When a person came in, we didn't ask them what their frequency was. We asked them what? What's your condition? Right? So think about what the variable is and don't necessarily get distracted by the frequencies. So our mode in this case is still gunshot wounds. Okay? Everybody got the point that I'm trying to make about that? Okay, very good. All right, and let's talk just briefly about the mid-range. Okay, the mid-range just really looks at the average of the highest and lowest values. So the mid-range is the minimum plus the maximum divided by 2. Okay, that's the mid-range. All right. What problems would we have with the mid-range? Okay, it doesn't include all the values. Very good. And what else? That's right. That's it. That's all it looks at is the extremes. If we have outliers, then it's going to really, really, really be out of whack. Okay, so the mid-range is very sensitive to outliers. And I did not leave a space for this, but you're right. It does not include all of the values. So if we have a data set that has extreme values, would it be appropriate to use the mid-range? For extreme values, we'd say no, because it's going to be affected by those extreme values. Okay. All right, so here's an example with a typo. Listed below are recent, that should say, annual compensation amounts for these chief executive officers. Mullally from the Ford Company, Jobs from Apple, Kent from Coca-Cola, Otonilli from Intel, McNerney, you can read all that. Okay, find the mean, median, mode, that should say, and mid-range for the given sample data. What is particularly notable about these compensation amounts? Explain which value is the best measure center. I want you to take a second and do that on your own at your desk. Okay, what'd you get for the mean? $0.0074.
2 zeros.
Okay. .4. I must have an extra digit or something.
898.
Okay, got it. Okay. Because the mean is going to be between these numbers. It can't be greater than all of them. Okay, very good. All right. And what about the median? 14,765. Okay, 410. All right, very good. Mode, no mode. Okay, excellent. And what about the mid-range? 844,121. Okay, got it. All right, is that it? Okay, very good. All right, so we've got these 4 different measures. And in this case, they're pretty different, right? Which can tell us something about the data, but we won't talk about that right now. Okay, what is particularly notable about these compensation amounts? If one guy got ripped off, I think he was okay, but somehow I guess he chose not to get paid or whatever, a salary. He was only getting $1. So we have a what? An outlier. Okay. So then in that case, which value do you think would be the best measure of center? The mean, right? The mean. No, I'm sorry. The median. Okay. The median. Okay. Why would we not use the mean? We got that extreme value, the outlier. The mid-range, that's all it looks at is those extreme values. And then, of course, in this case, the mode doesn't even exist. Okay? All right, questions about that? Okay. For the mean? Okay. All right, and we'll look at the calculator a little bit, I think, before we leave today. Okay, because we're not going to do these things by hand very much. All right, listed below are the number of manatee deaths caused. Okay. What's the mid-range?
Just one less than
Okay. All right, this is going down in history, so we got to get this right. What is it, 9 million? Okay, got it. All right, 9,814,293. Okay, that looks a little better. Okay, very good. All right. Okay, questions about that? Okay, good. All right, so we were talking about these manatees. And it says the data are listed in order for each year of the past decade. One important feature of the data is not revealed through the different measures of center. Okay, I won't go through calculating the measures of center right this second. But what do we not know about this that's probably important? Cause of death? Maybe, but something about the numbers here that we don't know. The years? Okay, well, that's getting close to it. They tell us that it's listed in order for each year. So what might we want to know about? How things are doing what? Now, and what else? What was that last letter in that CVDOT? Time. How are these deaths changing over time? We need to try that to change some things about the way that we're protecting the manatee or whatever. Okay, so yeah, we could find the measures of center, but something that would probably be more interesting to us in this case is time, since we know that this data is given to us in order of each year. Okay, they also have some additional critical examples regarding the measures of center. They had 2 really good examples. Okay, just because we see digits doesn't mean we should calculate a mean. So in this example 6, it says, for each of the following, identify a major reason why the mean and median are not meaningful statistics. Okay, So here in A, it's zip codes of the author, White House, Air Force Division of the Pentagon, Empire State Building, and Statue of Liberty. Why would we not calculate a mean or a median for that? It's qualitative data. Very good. Zip codes are qualitative data, and we don't calculate a mean for qualitative data. Okay, the rank of selected statistics books. Why would we not calculate a mean for that? Let's see what they say. The ranks reflect an ordering, but they don't measure or count anything. So the rank of 1 is from a book with sales substantially greater than the book with rank of 2, so the different numbers don't correspond to the magnitudes of the sale. When we talk about ranks, what level of measurement would rank be? That's something that you should have studied in chapter 1, I think. Is it nominal, ordinal, ratio, or interval? Ordinal, okay? So remember, one of the things about ordinal was we can put the data in order, but we can't calculate precise differences. So since we don't have those precise differences, to calculate the mean wouldn't really tell us anything. Numbers on the jerseys of the starting offense for the New Orleans Saints when they won the last Super Bowl, as of this writing. Okay, why would we not calculate a mean or median for this? Okay, it's categorical data. It's just a label to identify the player. Okay, very good. Okay, and then this next one, example 7, consider this. It is well known that smaller classes are generally more effective. According to the National Center for Education Statistics, California has a mean of 20.9 students per teacher, and Alaska has a mean of 16.8 students per teacher. These values are based on elementary and secondary schools only. If we combine the two states, we might find the mean number of students per teacher to be 18.85, as in the calculation shown below. But is this the correct result? Is it? No. Okay. Why is it not? Because we don't know how many values went into the average. Okay. Maybe to get this 20.9, they only surveyed 2 classes. And then to get this 16.8, they surveyed 30 classes. Right? So if that was the case, the 30 classes would have more influence than these 2. Does that make sense? Okay, so when it comes to finding the average, we can't just use averages. Okay, we have to know something about how many values went in to calculate the average. All right, very good. So that brings us to the next topic in the handout, calculating the mean from a frequency distribution. Okay, and I put right next to this calculating a weighted mean, because the formulas are essentially the same, we just use slightly different variables. Okay, so the formula for calculating the mean from a frequency distribution is x bar, and I'm going to put the approximate symbol. We'll talk about that in a minute. But x bar is approximately the summation of x times f divided by the summation of f and that's f. Okay, that's going to be our formula for calculating the mean from a frequency distribution. Okay, where we're going to let x equal the midpoint of the class. And I think it's obvious that f is the frequency. Okay, we'll come back and talk about the weighted mean in just a second. But here we have frequency distribution that we talked about earlier. Hopefully you saw the video on it, where we've got ages of our Math 120 students, 52 students, and the frequencies. Okay, we've already prepared this frequency distribution. Frequency distribution is a tool that separates our data into classes. Okay, and then from those classes we count how many values fall within each class. Okay, one of the things, just as a review, that we talk about with our frequency distribution is the class width. Looking at this frequency distribution, what's the class width? Okay, the class width, by definition, is the difference between consecutive lower class limits. These things, quick review, these are the lower class limits. Okay, they're the smallest values that can be included in that class. These are the upper class limits. And so to figure out the class width, it's the difference between consecutive lower class limits. So 23 minus 18 gives me 5. Okay, 28 minus 23 is 5. You could also do consecutive upper class limits, consecutive class midpoints, consecutive class boundaries, all right, consecutive whatevers. Just don't do upper class limit minus lower class limit, because that'll be wrong. All right, so that's our class width. The class midpoint is the point halfway between the upper and lower class limit. Okay, so in this case, to get the class midpoint, it would be 18 plus 22 divided by 2, which is what? 20? Okay, 20. Okay, and like I said, once I've done that the first time, I'm not going to continue to do that all the way down, because I can just use that class width, keep adding it to get the successive class midpoint. So this one is 20. If I add 5, we get what? 25, add 5 again, 30, 35, 40, 45, and 50. Same thing we'd get if we added the lower class limit and the upper class limit and divide it by 2. Okay? All right, so we got that. So when I apply, these are my x's, okay, for the formula that we just talked about. These are my frequencies. Okay, we saw that summation symbol again. We said x bar is approximately the summation of x times f divided by the summation of f. So what I'm going to do is take each of my x values and multiply it by the corresponding frequency. So 20 times 23 would be what? 460. 25 times 10 is 250. 30 times 11 is at 330. 35 times 3 is 105. Okay, 40 times 4 is 160. 45 times 0 is 0, and 50 times 1 is 50. Okay, add those up real fast. Well, this is just x times f. So this part of the formula. And so when we add it, we'll have that sum there. Okay? What'd you get? 1355. Okay, 1355. And so we get 1355 divided by the frequencies should add up to the total number of values in our sample, which in this case is 52. Right, we got 52 values. Okay, we got 7 classes. Well, it said it in the description, but also if we added the frequencies, they add up to 52. And so when we divide that, we get what? Okay, 26.06. Okay, so looking at the values and also the distribution, because we can't just look at the values, we have to consider how many are in each class. Do we think 26 is a pretty good measure of the center of our data? Okay, yes. Is it an exact value for our sample data? No. Okay, what's one of the advantages of the stem and leaf plot? Did you look at that? Okay, if you hadn't, make sure you go back and look at it. What's one of the advantages of the stem and leaf plot over a frequency distribution or a histogram? Shows the actual values. Okay, we don't know the actual values here. I've got 23 values between 18 and 22, but I can't tell you what they are. However, I'm going to estimate them to be 20. And so since I'm estimating here, this thing can only be an estimate. Okay, so maybe a pretty good estimate, but nevertheless, that's what it is. It's an estimate. All right, I got about 20 minutes. Okay, questions about that? Okay, very good. All right, let's put our hands a little bit on the calculator before we get done for today. So hopefully you brought your calculator. All right, let's run back up here and look at, let's say the manatee deaths. All right, let's say I want to use my calculator to compute the average, or I'm sorry, I shouldn't use that word, the mean number of manatee deaths. Average, the word average can be used to talk about any measure of center. It could be the median, the mode, the mid-range, whatever. Although most of the time when we hear average, we think about the mean. So since we're talking about several different values in this course, we won't use the word average. Okay, we'll use the mean if we're talking about the mean. Okay, but anyway, on my calculator, let's get that out of there. First thing I'm going to do is put the data in a list. So we'll go right here to stat. Okay, there are videos already online that show you how to do this, and of course I'm recording now. I hit stat, and then I'm going to select edit. It's already on the edit menu, and we've got option number 1 there. If you happen to have data in your list, then you arrow up to the list name, hit clear, and enter, and that gets rid of all of your data. Okay, so if you got a list of data and you need to clear it out, that's how you do it. Okay, but otherwise we're going to go ahead and list those manatee, the number of manatee deaths. Okay, just hit enter after each value. Okay, our calculator will be doing a lot of work for us, saving us a lot of time. So we want to make sure that we take a second and go back and look to make sure we type the numbers in correctly. Otherwise, it's going to give us the wrong answer. Okay, all right, I've got my data values in there. So now I'm going to go to stat again. What's that? Okay. All right, and then we're going to go over to calc. All right. And we're going to do one variable stats, which is number 1. And we tell it where the data is. The default is list 1, which is where I put my data. But if I wanted to say it anyway, notice here on keys 1 through 6, in blue it says L1, L2, L3. So that's how I can tell it which list my data is in. So I'm going to say second L1 and then enter. All right, and it gives me more information about the data than we've even talked about so far. But right up top, we can see that we have a sample mean of 82.7. Okay, that would be our mean value. All right, that was easy enough, right? Yes. Okay, very good. All right, well, what about from that frequency distribution? We don't want to have to go through and type 20M 23 times or, you know, whatever, however many different values. So to do that, we're going to use toList. So I'm going to go back to stat, still on edit. I'll put this in L2 and L3. In one list, I'm going to put my class midpoints. All right, so that was the 20, 25, 30, 35, 40, 45, 50. I think that was it, right? Yes? Okay, good. All right, and then in the second list, I'm going to put my frequencies. So we'll arrow over to that list and put in the frequencies. Make sure they match up with the class midpoints. So I got 23, 10, 11, 3, 4, 0, 1. All right. And so this time we're going to use a slightly different syntax. Syntax is the language that you have to speak to a computer or a program in. So this time I'm going to do one variable stats. This is for a frequency distribution. And I'm going to tell it where my midpoints are. Comma. The comma is right above the 7 key, I think. And then I'm going to tell it where my frequencies are. Okay, we tell it which list those values are in. So we'll still do the one variable stats like we did before. We'll say where our midpoints are, which mine this time are in X2. I'm going to use the comma above the 7 key, and then I'll tell it where my frequencies are, which is X3 or L3 is where I put mine. Okay, so let's do that. I'm going to go back to Stat, go over to Calc. That's where we find one variable stats. Okay, I'll do second L2, comma, second L3. Oops, my comma didn't come in. Second, insert, comma. All right, good. And enter. Okay, and so we get 26.06. We probably should have said, I think we said 05 when we did it before by hand. Did we say 06? Okay, good. All right, 06. So we've got the same thing using our calculator. All right, questions about that? Okay, good. All right, you want to be very comfortable with doing that. All right, let me just talk a little bit more about this weighted mean before I let you go. Actually, I don't think I put an example in there. I got to go back and put that in the notes. But let me just tell you what the formula for weighted mean looks like. And in fact, I'm going to go back to where we had the other one so we can compare. Okay, the weighted mean, still x bar, is equal to the summation of x times w divided by the summation of w. Okay, where w is the weight of each value. And x would be the values. So when we have a weighted mean, or why do we even use a weighted mean? We've got some values that count, their importance is different, okay? Or their weights in general are different. For instance, letter grades, or your average at the end of the semester, okay? When you get your report card or whatever, you look and you calculate your GPA. That's what I'm trying to say. That's a weighted mean, right? It comes from, it's based on what? Okay. All right, so let's say you take Math 120. You get an A in that. That's a 3 credit hour course. All right, what else are we taking? That Bio 210. What do we want to get in that? C. That's what I thought. All right, let's say we're taking a little sociology. We're going to get an A in that one too. It's 3 hours, and then one more class. Whatever it is, let's get a B in it. Public speaking, okay, that's also 3 hours. No, but Bio 210 is 4 credit hours. Yeah, these are credit hours, okay? Public speaking, SPC 205, okay? So the credit hours in this case would be our weights, credit hours, right? Because, you know, you got this 4-hour C, this 3-hour A, that doesn't come up to a B, does it? No, because the C has a little more what? Weight. Or, well, in this case, more weight because Bio 210 is 4 hours. Okay? So, yes, on the scale, and A is what? 4 points. B is 3 points. C is 2 points. D is 1 point. And then, of course, the F is no points. All right? But the hours still count. All right? So if we wanted to calculate our GPA, in this case, my X value would be 4, 2, 4, 3. Okay? I'm going to summarize that here. And then my weights are what? Was it 3, 4, 3, and 3? Okay? So our mean is the summation of X times W over the total weight. This is the same thing as that frequency distribution. Instead of weights, we had what? Frequencies. All right, do you see that? So it's really not two different formulas. They're the same formula, just a different application. So we've got 12 plus 8 plus 12 plus 9 over the total number of, our total weight, which is what? 13. Okay, and so we get 20, 32, is 41 divided by 13 is what? 41 divided by 13? Can anybody help me? $3.54? 1.5? Okay, very good. All right, so that's how we calculate a weighted mean. All right, and you could still put these values in the calculator if you needed to get the mean. So going back to that example that we had just a second ago, if we had averages and we knew how many people went into each average, then we could use that to calculate averages, but it would have to be a what? Weighted mean. Does that make sense? Okay, very good.